Foo. And the sake of can foo. Suppose foo, where the sake of contradiction. Contradiction. That what do you want to suppose? Let capital be an upper bound of V. Suppose for sake of contradiction that should be.
But M is greater than. Sorry, M is less than.
M is less than. Then that day I proved something else. Should A equals lambda if and only if, say should A down, should A equals lambda if and only if I had two conditions. I told you this is what we use as a sort of practical, it's not the definition, it is a result. For each A belongs to A less than or equal to lambda. What is the second thing I said?
For each upper bound of A.
No, I final thing I got the result. I told you that this is what we use when we prove soup. Although other things are correct. Now when you go like this, you get stuck with, but now what should I do like that? For each what? Buddha, can you remember? This is the one we use. Although in English you can say many things. In an analysis class, the thing I wrote, I told you this is kind of like the practical definition. So this should be like your family name. You need to know it right away. It must be on the tip of your tongue.
For each epsilon greater than 0. There exists x epsilon of that's an element of A. Such that lambda minus epsilon is strictly less than A epsilon.
This is what we use when we are doing. Other things are, they are English statements, most of them it says one is an upper bound of A, any upper bound, if you take any upper bound, it is greater than or equal to 1. So that is, it is correct, of course, it is absolutely correct. But in analysis class, you have to get used to epsilon. So one thing, sometimes this book, sometimes he uses epsilon at unnecessary places, but at necessary places it is not used. So this is the one we are using. Somehow when what you told me so far, all of them are correct. But since you know it, I will erase this because I want you to get used to epsilon language. In order to do an analysis, you need to be able to use epsilon all the time. Because when you write in English, it's kind of discouraged. So according to this, then we say that, as you told you, let's say x belongs to E. Then you will then there exists Because we are going to do first part. That's what you do that. You see. There exists, you said P belongs to Z plus, such that you said X is equal to P over P plus 1. You said clearly. First you said P greater than or equal to P plus 1, but then you changed clearly less than P plus 1, thus X, which is equal to P over P plus 1, is strictly less than 1. Hence, this is X belongs to E. If you want, you can write arbitrary. B, in English, BE, arbitrary. Hence, X less than 1, hence, again, for each X belongs to E, X less than 1. So, first part I have proved. Then if you want to prove the second part, you need to begin with let epsilon greater than 0. Then you have to show that there exists an n belongs to, there exists some n over, sorry, 1 minus epsilon must be strictly less than some epsilon. So you have to do some rough work. Always I say that. Because in his case, he has told several times in the book. Now we are looking at 1 minus E. 1 minus epsilon. We want this to be less than some A epsilon. Any A epsilon is of the form n over n plus 1. If you want, you can put n epsilon over n epsilon plus 1. Then what this is 1. So we need 1 minus epsilon must be strictly less than. For the time being, let me not write n epsilon. This is rough work. If I can show that there is some n like this, I am done. So if you simplify this thing, what will you get? This 1 plus n plus epsilon times 1 minus epsilon is strictly less than n. So you can say let epsilon greater than 0. Now you can see it should be, if I want to divide this and that, let's see what will happen anyway. Then you get n plus 1 times 1 minus n times 1 minus epsilon plus 1 minus epsilon is strictly less than n, right? So when you cancel n to n, you get minus n epsilon plus 1 minus epsilon must be less than n. I cancel, no? N cancel, minus n epsilon must be less than 0. Therefore you get 1 minus epsilon less than n epsilon. Therefore n must be greater than 1 minus epsilon over n. Silly guys, silly. 1 minus epsilon over epsilon. So that's the rough work. Then what will I write? Here, let epsilon greater than 0. Oh, if you want, be arbitrary. Now what am I going to write?
Choose n belongs to Z plus such that n is strictly greater than 1 minus epsilon over epsilon.
Choose n belongs to Z plus such that
n is strictly greater than 1
n is strictly greater than 1 minus epsilon
over
over epsilon. How can I choose such an n?
half medium property.
Choose n belongs to Z plus such that this thing by Archimedean property. Median property. No. Choose n. So this is a particular epsilon. So I will write choose n epsilon. So I start like that. then we have to show that 1 minus epsilon is strictly less than,
in our custom.
oh, 1 minus epsilon is strictly less than n epsilon. We need this one. This is what I need. So I have chosen n epsilon this way by Archimedean property. Then, I cannot write away. You need to go backward without writing this right away. Uttara, do you follow? Then definitely I can say then n epsilon greater than 1 minus epsilon. Sorry, not this. I am going to make all of them up. You can go backwards too. Since n greater than, n epsilon greater than, what is it? 1 minus epsilon divided by epsilon. Now, I am not going to write all the lines, then you can write this line, this line, this line. Can you see what I am saying? Then you come to this level. I am not, if I were solving the problem, then I write therefore 1 minus epsilon less than n epsilon, therefore this one, therefore this one, therefore this one and this one. Right? After, then I go here. This line, then this line, then this line, then this line, then this line. Right? All of them I prove. That is 1 minus epsilon less than n epsilon over 1 n epsilon plus 1. So I have proved 1. I just not trying to, because nobody knows what 2 means. Anyway, I have proved for it x belongs to be x less than 1. I have proved first line. Then I have proved the second line also. Thus, should be is equal to 1. So you need to be able to use epsilon because continuity, differentiability, series, sequences, integration, everything is with the epsilon. So you need to be comfortable with epsilon language. That's why I did that one. Now here, actually for Lim Soo, he has not used epsilon at all. That's not good. Can you see how you need to be able to write a little proof like this? If you once you write in English, what happens is it's very good. That's how what this English books. Because their mother tongue is English, so they can write. But if you read it, you cannot understand. So regardless of how good you are in English, maths itself is difficult. When you write in another language, it's difficult. But when you write using this epsilon language, it is very clear. Other people are clear. But that's why American people, when they write books, epsilon is over there. Everywhere, not over there. Everywhere. They write books so the reader can understand. English people write books to show that they know it, but you don't know it and you cannot learn it. That is their style. I'm not saying it is bad. If you read and understand English books, then in a way you are better. Because it doesn't give all the details. So in P also, for instance, this set, what is the infimum, for instance?
So 0.
No. What is the infimum of this set?
Half.
1/2. Half. Yes. Again, I did not write, I guess the other day I didn't write if A is equal to mu, if and only if, Roman 1 for each. Simple A belongs to capital A greater than or equal to mu. Mu is a lower bound. Then the second line should be mu is the greatest lower bound. For each epsilon greater than 0, there exists A epsilon belongs to capital A such that A epsilon is strictly greater than mu plus epsilon. If you increase mu just by tiny little bit, that is the advantage of writing epsilon, because epsilon can be 10 to the minus, anything. So that epsilon language really convinces somebody. So if you are going to prove if A is equal to 1/2, best thing is to follow this thing, because if you are going to say let M be another lower bound, that is correct, but to the contrary, to do analysis, because especially in your case, functional analysis courses, real analysis courses, special theory courses, when you are in the United States, maybe some many other courses, harmonic analysis like Dr. Rabat, all of them you have to be very comfortable using epsilon language. If you say in English, of course it is correct, but to prove things, especially it is a difficult thing. This one is easy now, without, you could have proceeded the way you said, but then it is method doing it, the method you do it does depend on the individual. Now when you are using epsilon language, one way. Alright? So you have to be able to prove should E in phi. Now let us, because I'm kind of, shall I erase or you want to?
So can I move the chair a bit?
And coming back to this set, in any proof, this must be there somehow, regardless of how you proceed. You have to use the Archimedean property. Sometimes he says Archimedean principle. That Putra who comes only for lunches, is he in touch with you? No.
A little bit, yes.
He doesn't come, no?
Kind of, yes.
Because if someone is not really serious, coming here is meaningless. Because analysis is not a spectator's game. You just cannot watch others prove, read others' books, you won't take a mathematician. Now, let's see this one, the way we can do. Prove that. Very little things. Limit n tends to infinity. For instance, 2n plus 1 over 3n plus 7 is equal to what? 2 over 3. Uta, you will prove that. So how do we prove? What is the method? I mean, limit of, say, some n tends to infinity. Xn is equal to some number L. What? If and only if. These are very little things, but by proving little things, you will come to the crack of mathematics. Now we are talking. So means this and that. So limit is we have if and only what?
So Xn is an element of a Cauchy sequence, right? According to our definition up to now.
No, you are saying the result. If this is a convergent sequence, any convergent sequence is Cauchy, any Cauchy sequence converges, that we are going to prove, I guess, in this chapter. But I am asking, it's not that, I am asking, I mean, limit, now I showed you, if you want to prove sup A is equal to say lambda, you have to see, you have to prove that every A belongs to lambda must be less than, every simple A belongs to capital A must be less than or equal to beta. Then I said, if you take any epsilon greater than 0, and if you subtract that epsilon by lambda, then there must be some element bigger than that in the set. That's why I said sup capital A equals lambda, if and only for each simple A belongs to capital A, simple A less than or equal to lambda, then for each epsilon greater than 0, there exists some A subscript epsilon such that lambda A epsilon is strictly greater than 1 minus epsilon. So, no matter what set you get to know about the sup, that's the way you prove it, by justifying it is an upper bound. Actually, what the second one says, anything less than lambda is not an upper bound because A epsilon is bigger than anything less than lambda. That's what we are proving. But what I am trying to say is, I mean, in English, though it is correct, in maths, in analysis especially, we have to get used to the language of epsilon. Here, limit n tends to infinity, xn equals L. If, when you see this thing, Putha, what do you mean, what do you feel about xn?
Sup Xn.
No. Your mother is a doctor, no? So, she asked you, hey, that you, who is just 18, tell me, tell me what you mean by saying limit n tends to infinity, xn is equal to L. What does it? What do you tell her? I am not asking a mathematics question. You go home, mother looks at your nose because she has MBBS doctor, no? So she has been to campus. Then she may ask me, hey son, I did MBBS, what the hell are you doing? You write good lean, then you send n arrow infinity, you write xn equals L. What does it mean, Putha? She doesn't know any mathematics, assume. Maybe those who entered to medical faculties many years ago, they are smart people, they are, but eventually they get to cram books and so on, ended up in different area. But still she may ask, what is this? Say suppose I replace L by 7. I say limit n tends to infinity, xn is equal to 7. What comes to your mind about xn?
It
is approaching 7.
Approaching 7. Yeah, it's kind of correct. But what do you say, Buddha? If your mother is a doctor, no.
Housewife.
What is she? Housewife? Maybe so you are lucky, she cooks well, you eat. You have a servant at home, don't you? Who cooks? Mother cooks? She is. Because when I look at you, you look like a good boy, so mother must be good. Otherwise, how can he be good? Anyway, what do you say, Buddha? If your mother asks you, if she hasn't been to even medical college, and maybe she up to grade 8 or grade 12, those days, you know. So, but she may look at it this and what is this, Buddha? What is the meaning of limit of xn is equal to 7?
So when the n value increases, the xn value gets closer and closer. Every xn value gets closer and closer to n.
Yeah, if you say limit xn is equal to 7, what you have to get the feeling, when n is so large, xn is so close to L. That's what it means. When n is so large, xn is, in bad English, doesn't matter, damn close to L. It is that's but that language cannot be used to prove. There is no way of justifying when n is getting larger and larger, xn is getting closer and closer to 7. I mean, how can you do such a statement? So there is a way we prove. We discuss. What is it?
For each epsilon greater than 0.
Okay, very good so far. For each epsilon greater than 0,
There exists capital M belongs to Z plus.
there exists capital N belongs to Z plus
Such that modulus xn minus L is strictly less than epsilon for each simple n greater than or equal to capital N.
very good. Actually, if you look at this definition, this is the definition. No?
If xn minus L is strictly less than epsilon.
Yes, very good. So what this says is the modulus of xn minus L can be made as small as we please for large values of n. That's what in English this means mod of xn minus L can be made as small as we desire by making n larger. That's what it means. So this is the definition. Even in your case, you don't remember the definition. That's not good. Now, anyway, regardless of the book, we have to know this. I mean, so let's prove it. So this is a very simple problem. Okay, proof. If you are, so now this is the definition. So what is my first statement in the proof?
Let epsilon greater than 0
Let epsilon greater than 0 be arbitrary.
be
Now, what do I need? What should I do? I want to show that there is an integer capital N such that this thing minus modulus of this thing minus this thing less than epsilon for any n after that capital N. Right to that? So let epsilon greater than 0 be arbitrary, then I write notice that 2n plus 1 divided by 3n plus I squared 7 minus 2 over 3 is equal to 3 times 3n plus 7, 6n plus 3 minus 6n minus 14, am I right? Then 6n minus 6n cancel, you get minus 14 is plus 3 is minus 11 over 3 times 3n plus 1. 2. So now let's put absolute value here. Now let us put absolute value here. Let us put absolute value here. This is equal to 11 divided by 3 times 3n plus 7. I said, notice that. Somebody can write, observe that. Somebody else can write, it is clear that. Right? Yeah, many ways of writing. Now I want to make this one is smaller than epsilon after some capital integer n for any n. So now I have to do always rough work. This one. Let's see. Okay. So I want to say 11 over. Oh, I slip. Slippery floor. Oh my gosh. If I fell down. Over 3 times 3n plus 7. This must be less than epsilon. No, then you get 11 must be less than 9 n epsilon plus 21 epsilon. Am I right? Correct, no? 9 n epsilon. Then you get 11 minus 21 epsilon divided by 9 epsilon must be less than n. Right? This is the condition we need. So, put that now, what having seen that, what do I write here? I will give you a hint by Archimedean property.
Let n be greater than, strictly greater than 11 minus 21 epsilon divided by 9 epsilon.
By Archimedean property, there exists
N strictly greater than.
capital N belongs to is n plus such that capital N greater than what?
11 minus 21
11 minus 21 epsilon divided by
9 epsilon.
9 epsilon. I got capital N according to here. I got this. Now what do I have to do? I have to choose any n greater than or equal to n. Let n belongs to Z plus be n greater than what do I write? Capital N. Right? Let n belongs to Z plus B. I should know this is
Yeah, it's okay.
difficult to erase, no? No.
No, I don't think so.
Younger Buddha is here, no? Let n belongs to Z be greater than n. Thus, n greater than 11 minus 21 epsilon over 9 epsilon. No?
Yes.
Now, therefore, I put it. Therefore, you get this line, you get this line, like that. Therefore, after writing this thing, because you do here rough work, then to the proof, sometimes you, if you want, you can say that n greater than n, this thing, the hence 11 over 3 times 3n plus 7 is less than epsilon. Thus, mod of 2n plus 1 divided by 3n plus 7 minus 2 by 3. That's the answer. So I took an integral, so we said plus b, if you want such that, I don't know whether this English is correct. Sometimes I'm on the fence about English grammar. Thus, this thing less than epsilon, hence, for each n greater than, we have mod of 2n plus 1 divided by 3n minus 7. Oh yeah. Minus 2 over 3 less than epsilon. So finally what we are saying, for each n greater than capital N, we have this thing thus. Limit n tends to infinity. 2n plus 1 divided by 3n plus 7 is equal to 2 by 3. So you need to be able to write very simple proofs of things like this. You have to use the definition to say so. Can you see? You have to, doing analysis is doing this. Now suppose you want to prove that 1 over n is Cauchy. I am going out of the lesson because you have to get used to this thing. You are not doing it. That's why. So, let's see. I want to do that. Do that. Can I erase?
Yeah.
But I will not take notes, so?
Yeah. This.
You get from me. You should prove in your own, you write something, prove it. Get used to the analysis language here, because according to the books, you are not, he proves only limit of 1 over n is equal to 0. You have to prove, 3 or 4 things so that you know how to use. Prove that, say, for instance, are these helping you or not? Prove that 1 over n is Cauchy. This is a Cauchy. Yes, prove. Before proving, we have to know the sequence xn is said to be Cauchy. If when I, for definitions, I write only if. If you want, you can write if and only according to this book, but after you go out of this book, just use if. Xn is said to be Cauchy, but
There exists n greater than there exists n belong to Z plus for any
no, I want to stop you and I want to ask. Your mother is going to ask, what is this Cauchy sequence? She knows Cauchy, Umiris and etc. What is the meaning of Cauchy sequence according to you? Say like Xn is Cauchy, what is in your mind about Cauchy sequences? Because see, to do maths, intuition and insight. That's what mathematics is all about. When you say a sequence is Cauchy, what comes to your head? What comes to your head, Buddha?
So when the n value is very big, the xn values are very close.
Okay, when n is so large, distance between any two terms can be made as small as you decide. Cauchy sequence is that if you take any by making, I mean, without going back by making, without saying that, if you take any two terms of the sequence, by making the value very large, value is very large for these two, the absolute value of, in other words in English, distance between these two terms can be made as small as you like. So that is the mean. That must be in the head, because if you are just going through theorems, proofs, okay, correct, and I understand, if you don't think, cannot do maths. Because mathematics is, if you are going to do a PhD in math, you will be given a problem that nobody has solved to that day. Then you have to think out of the box. Because you have an advisor. Advisor is the problem. If he knows how to solve it, he wouldn't ask you to solve it. He will solve it. So you have to have ideas. Do you understand something? You do a PhD with the big guy. Now, for instance, in this case, he will be doing PhD with the big guy. Even though he is big, he is giving him a problem that he cannot solve. But he can direct him if he is going to do something lousy. No, this is not going to work. But if he is very sure, he can insist, I will show you, let me do it. Like that. It is like that. Okay, so a sequence xn is said to be Cauchy. What would be the definition then? If and only if what?
There exists n for any nm greater than n, distance is
Distance, not the distance, no, now. I'm going to write what you say on the board.
xn minus xm is modulus xn minus xm is smaller than epsilon.
Did talk about epsilon.
You didn't say epsilon. Anyway, it is like you are not married, you are Baba yet, but you are talking about your wife. I will wonder where on earth your wife is.
For any epsilon greater than
Okay, this time you are talking correct. For every epsilon greater than 0,
there exists capital N
If you want belongs to Z plus such that
any such that for each nm simple nm greater than capital N,
comma
xn minus xm is smaller than epsilon.
not bad. He has seen something like this. Very good, Putta, very good. Now, now we have the sequence of our xn is 1 over n. We have to do that 1 over n is Cauchy. So in order to do so, what is the first line I should be writing? Let in the end here also, let epsilon greater than 0 be arbitrary. Now what do I need? Sometimes at the very beginning, it's good to write that way also. We need to show that. You can, let me do it that way, only for this one. We need to show that. I do it this way when I am finding it difficult to do it. Then I am buying time. We need to show that what?
There exists.
Okay. There exists. N belongs to Z plus such that for each nm strictly greater than capital N mod of xn minus, in this case But of xn is 1 over n minus 1 over m less than
epsilon.
epsilon. Now we are, if you are finding it difficult to write the proof, you can, by writing this way, you make the problem clearer to yourself. Now rough work. 1 over n minus 1 over m is n minus m divided by n m. This is absolute value, this is absolute value. So now n and m are equal, there is nothing to do actually. So we have to assume one integer is bigger than the other. So without loss of, this is how mathematics people have generality. My spelling correct? G-E-N-E, general. Must be. Assume that n greater than m. If you say n greater than m, then you get n minus m over n. So I want to show that this can be made very small by making, so I mean, this must be less than epsilon. Somehow we have to use, since n greater than m, so n minus m is n minus m. This is strictly less than n squared or m squared.
M square.
N squared? If I write n squared less than n m, no, m squared. No?
Strictly
1
greater
over
than m square.
I'm sorry?
No, m square.
M squared. No? So this is less than. Now you have m over n here. I'm sorry, I have chosen m less than n. So this is actually less than n over m squared. Now again we have to assume n. Upstairs I got n m squared. How can I write by one statement? I mean one letter. How do I replace? Either using n or either using m. Can I write n over m squared? I mean, I want to choose this. I want to say this is less than epsilon. So if I simplify this thing, I get n must be less than epsilon times m squared. Then because I have to get to one letter n o n, because with two letters I cannot do anything. How can I do it?
We need to consider capital N here.
So far we haven't considered, I mean, we don't have a capital N. No. We are trying to find, how do we find the capital N? We don't have a capital N yet.
So capital N needs to be greater than n.
What is capital N? What is a capital N? I don't know what it is.
The NMA must be greater than, over there for each NM greater than.
You are saying that. You are saying both N and M are greater than
Yeah.
N. So then I can replace N by
N.
capital N. M? Can I?
Yeah.
No.
No. Replace m squared with capital N. Because capital N is smaller than m.
Capital N greater than M. Therefore,
capital N less than.
both N and M are greater than capital N. Yeah, I'm writing it.
Yeah.
Then M, both are greater than capital N.
So m squared is 1 over m squared is less than capital N.
Therefore, M squared greater than N squared. Therefore, you are saying 1 over N squared is less than 1 over M squared.
Yeah.
So here you are saying N squared, right?
Mm.
Less than epsilon. So this is 1 over capital N less than epsilon. So then capital N must be greater than 1 over epsilon. Right? Am I correct or wrong? My capital N must satisfy that condition. M squared greater than N squared. 1 over M squared less than 1 over M squared. I guess it is correct, no? Anything incorrect?
There's a problem. The simple N is greater than N, capital N.
Simple N is bigger than capital N, so there is a problem here.
Yeah.
So what should I do then?
So if we replace from the beginning without going that far,
Oh yeah.
that 1 over simple N is less than 1 over capital N, and 1 over simple M is less than 1 over capital N, and their difference must be also must be less than 1 over capital N.
You are saying some. Now we have this 1 over N minus 1 over M, no?
Yeah.
So it is, we got N minus M over Nm. Okay.
Yeah, without going that path, I'm saying.
Without going this far.
Yeah.
Okay.
1 over simple N is, so N is, simple N is greater than capital N.
Simple N greater than capital N.
So 1 over N is strictly less than 1 over capital N.
1 over simple N is strictly less than 1 over capital N.
Similarly, 1 over simple M is less than 1 over capital N. Then 1 over N, simple N minus 1 over capital simple N must be less than 1 over capital N.
0 is here, 1 over capital N is here. No? You are saying 1 over N, 1 over M, 1 over M is bigger. So if you subtract 1 over N, whatever it is less than 1 over
Capital
N, because both of them are inside, you cannot go outside. So then without writing this sort of work, then therefore 1 over N must be less than epsilon. No? Then 1 over N less than epsilon. Then however, because now the thing not good is we are choosing capital N that we are going to use. It's not good somehow choose N belongs to Z plus such that N greater than 1 over epsilon, right? So now let me erase all of them and see whether we can come there. Good. Let's see whether it, right? Without a certain assume that in your M. Choose. You are saying capital N belongs to Z plus such that yes, in greater than 1 over. I am kind of silly. Okay, let's look. By Archimedean property, no?
Yeah.
Now let choose I guess this line the way I have written is incorrect. Let epsilon greater than 0 be arbitrary. We need to show that this thing without assumption to assume that n greater than m doesn't matter. Notice that now then nm be greater than capital N. Then 1 over n minus 1 over m absolute value. What is bigger from this one?
1 over m is bigger. No, we haven't chosen. Yeah. 1 over m is bigger.
1 over is bigger, no? This is right. Actually, this is less than 1 over n. This is less than epsilon. Right?
Yeah, 1 over m is less than 1 over capital N.
Yeah, we can write that part also. Right. So thus, I will make it quick because I want to do something else also. Thus, 1 over n is quotient. So the reason I am doing this kind of little things is you have to be able to do little things. Little things. Otherwise, you don't get to the analysis. No, you just go through this whatever proposition 4.4.1 or something. No? Now, shall I erase before coming to the lesson? Try to write nice proofs for little ones, then you get used to the epsilon. Somehow, it is like when you go to a lunch, first you eat the drink what?
Soup.
Appetizer, soup. Here we are also playing it. Soup. Have you heard the two words arithmetic mean?
Yeah.
What is it?
Addition divided by
If you are given x1 up to xn, then arithmetic am, arithmetic mean is x1 plus x2 plus n plus so on xn divided by n. Have you heard the word geometric mean? What is it?
x1 into x2 into x3 into root n.
Which root?
Root n.
Nth root. You know this one is always greater than or equal to this one? You know that. Can prove it also.
I haven't tried, but yeah. I think in the question like that.
This is called AMGM equally. Arithmetic mean, geometric mean, inequality because we use this here and there. Even for some problems in the book, it doesn't say it. I will, if you want, I can write the proof for n equals 2, 3, 4. You want it to?
No.
You think you can do it?
I can try.
Okay, so then I am going to assume that you know this thing. I will state it. AM, arithmetic mean, GM, inequality. let x1, x2 up to xn be positive numbers, say real numbers. These are positive real numbers. Then x1 plus x2 plus and so on plus xn divided by n is greater than or equal to nth root of x1, x2 times x. So this is I wrote it. So this one is a very useful one when you are solving some problems. So I am not going to do it. You prove it for n equals 2, then prove it for n equals 4, then prove it for n equals 3, then prove it for n equals 8, then prove it for n equals 7, then prove it for n equals 6, n equals 5. This is the method you prove it, but to write for any n right away, you have to have backward induction also. You don't know backward induction, no? So let's not talk about it. It's not difficult. Proving for n equals 2 is very easy. You say root x1 minus root x2, whole thing squared greater than or equal to 0. This is if and only if x1 plus x2 divided by 2 greater than or equal to square root of x1 x2. This is the proof. They are positive numbers. There are other things you can prove actually. Anyway, so I am going to assume that I proved it already. I proved for 2 already. I am going to assume that even though you cannot write for any n, you can prove like what I said. Now you can prove for n equals 4, then for n equals 3, then for n equals 8, then for n equals 7. Then for n equals 6, after 8 if you want you can go for 5 plus 6 plus 7 plus, however after 3 you have to prove it for 8. Okay, I am going to assume that you know A and B inequality and you can prove it at least for certain values of n, but general proof needs some what? Induction. To prove A and B inequality, you use forward induction as well as backward induction. You have to use both. But without using both by forward induction, you can sort of justify, not really prove. What else I was going to tell you? Okay, good. Now listen. So my intention was, again before starting the book, listen, because now I have to make sure I have to present the proof of theorem 5.9 that least up about you guys said you couldn't understand it, no? I will not do it today, that Putra is not here. Then let's see, we go to chapter 6. Now here, chapter 6, page 131, theorem 6.1.19. Then part 2 says, this one says, addition of two convergent sequences is a convergent sequence. Second one says, product of two convergent sequences is a product of, English is lousy. Product of two convergent sequences is a convergent, and limit of the product is product of the separate limits. And third one says, if you have a convergent sequence, you multiply it by the number c. New sequence is also convergent. Not only that, limit of the new sequence is c times the initial sequence. For part 4, no D, yes, 4, no A, B, C, D, only 4 it is. It says difference of two convergent sequences is a convergent sequence, and limit of the difference is difference of the limits. Again, like part E also. Part E, what I am meaning is you have to understand that now. If you again go back to part B, it says limit of the product is product of the limits. However, this is true for convergent sequences. He began from let A and B and B convergent sequences. Otherwise, this is not true. What I want to say is that if you replace Bn by An in part B, no, Bn by An, then you get limit of An times An is limit An times limit An. Can you see? If An is a convergent sequence, then An squared is also a convergent sequence, and limit of An squared is square of the limit of An. If this is true for 2, this is true for 3 also. 4, 5, by induction you can prove it. Actually you can prove if An is a convergent sequence, for every k belongs to Z plus, An to the k is a convergent sequence, and limit of An to the k is equal to kth power of limit of An. Then can I say today is too quick to ask it. Too quick to ask it. My mouth is today. That person, some days he brings a bottle of water, not today. So I'm going to assume that you know the meaning of sup, limit, bounded. You have to be able to prove these are for very little ones, not for big ones. Now, for instance, say, suppose A converges to L. Then A1 plus A2 plus A3 plus and so on divided by N. Arithmetic mean of An also converges to L. Geometric mean also converges to L. You need to prove these kind of little things when you are at home wondering. They are good exercise, little. Now I told you that limit of An is equal to L, limit of N squared is equal to L, limit of any N raised to the power, any number, 2025 is also L raised to the power 2025. The limit of then An raised to the power N is what? Let me go to a different problem. An converges to 1. That means limit of An is equal to 1. Therefore, limit of An squared is also equal to 1. Limit of An to the 25 equals to 1. Limit of An to the N, therefore, must be equal to 1. After when you do these exercises, ask me to come back to this. Now what you said is absolutely false. They are entertaining problems, so we will be coming to them. One more thing. Very important one. So let's take A, capital A, it's a set. A is a subset of R. A is non-empty. A is bounded. Then A has something. What is it? Sup. Sup A exists. Let's say you don't write first. without forget about word. Then you know how to prove super equals lambda. No, if you are given the set capital A, now you know how to prove super equals lambda. No? What do you prove?
If any simple A belongs to capital A, it is simple A is smaller than lambda.
Yeah, right. Smaller than or equal.
Smaller than or equal lambda.
Mm-hmm.
Lambda for any epsilon greater than 0, lambda minus epsilon is smaller than a epsilon for any a epsilon belongs to capital A. For some
For some epsilon. Anyway, good that he remembers something, but I got the impression maybe you are not doing homework, do you?
I'm doing.
Okay, I want to do something. Show that there exists a sequence section, sequence sequence A, such that for each n belongs to n, A belongs to A, and limit n tends to infinity, A is equal to lambda. Sup is a limit of some sequential of the members belong to the given set. For inf also this is true. Sup is the limit of the members of the set capital A. Very good. Yeah. Can you see what I am trying to say? Show that there exists a sequence A n such that for each n belongs to A, for each n belongs to n belongs to A, and limit of n is equal to lambda. So these are little very useful results. Inf also this is true. How do you prove it? We have to find the A in, no? That's the thing. Right. Have you ordered tea from that
Yes.
place? We have to find the sequence, no?
Yeah.
In capital A. And it must, limit of that must be lambda.
The first part of the proof can be done like A must be less than lambda. So because A is an element of A and super A equals lambda. So that part can be done. The second part is the how to choose an A.
Oh, since we have, after tea break, we have to go to the book. But I'm kind of discussion, are these kind of discussions very helpful to you?
Yeah.
I have shown that sup A equals lambda. This Uta told me, for every A belongs to A. I should not write. For each A belongs to A, he said A less than or equal to lambda, and for each epsilon greater than 0, there exists you don't learn English. I'm spelling from me, no? So I'm saying that exists. A epsilon belongs to A such that lambda minus epsilon is less than epsilon. Then, yeah, lambda minus epsilon. You know that part, that's very important. So what I do is, I take,
Yeah, you choose from the second thing. You can choose A from A since lambda is the supremum. You can choose some elements A n from A such that the second property holds.
can A lambda minus A n less than A n, lambda minus epsilon less than A n.
Yeah, so those.
What is your A? You didn't tell me what this A n is.
Yeah, you have to choose it since lambda.
How?
Is,
How do I use?
let epsilon greater than 0 be arbitrary. Since lambda is the supremum of A, choose A n of that's an which is an element of A such that lambda minus epsilon is strictly greater than A.
Strictly less than A. Yeah. This is what I will do. I take any sequence limit 0. Can you give me a sequence whose limit is 0?
1 divided by n.
1 divided by n. I take lambda minus 1 over 1. I choose A1 like this. That's what it says. If I take my epsilon is 1, then there exists A1 belongs to A like this. Right? Then I choose A2, lambda minus 1 half less than A2. I choose lambda minus A 1/3 less than A3. From this line, for the first line epsilon is 1 over 1, for the second line epsilon is 1 half, for the third line epsilon is 1/3. And then I go for, I am using only this line. And lambda minus 1 over 5 less than A5. Bingo, bingo, bingo. Lambda minus 1 over n less than A. I can use an S1. My epsilon is 1 over 1, for A1, I choose epsilon to be 1 over 1, for this thing 1 over 2, this thing 1 over 3, like that. However, you know that A1 definitely less than or equal to lambda, A2 less than or equal to lambda, A3 less than or equal to lambda, A4 less than or equal to lambda, A5 less than or equal to lambda, A less than or equal to lambda. Now you remember the squeeze test.
No, we do it.
We haven't done it yet? No, we have. He says,
On the top.
I squeezed this. Only today we are doing. Okay. I thought we have done. Anyway, now we are doing it. No, what this squeeze test says is that do it after tea.
Okay.